Everyone, welcome to the channel. So in this video we're going to focus on the introduction to groundwater flow modeling using MODFLOW and GMS. So we're going to focus on this topic called groundwater aquifers and their classifications. So now let's get started. So in the second part of this course, the concept of groundwater flow modeling using MODFLOW and GMS. So during this section we're going to discuss one of the most important definition in groundwater, that is groundwater aquifers. So actually the groundwater aquifers are where the groundwater are stored or where the groundwater are transmits. The relation between aquifers makes us understand how the groundwater flow in our world. Actually we can classify the groundwater aquifers into four main types. So aquifer is generally an aquifer stores and transmits water. It consists of an unconsolidated deposits like sand, gravel or sandstone. So aquifer contains mainly of sediments like the sand, gravel and sandstone, and usually it is a porous media. It has an ability to store and transmit water. So as we discussed earlier, as you can see here, the aquifers is in blue color, in which the groundwater can be stored and transmit, and where the well could be drilled. So from this diagram here, this section of this part of the section, which is called as an aquifer, which has an ability to store and transmit water, and this is the artesian well. So artesian well is a well that brings the groundwater to the surface without pumping because it is under pressure within the body of rock or the sediment known as an aquifer. So next we're going to focus on aquiclude. So the aquifer that stores but don't transmit water. It could be a clay and has an impervious boundaries. So the clay is an example for aquiclude. Actually the clay can store water, but actually it cannot transfer water through it, so it can't be defined as an aquifer. So the third type is Aquitard. So the aquifer that transmits but don't store. It could be a fractured or unfractured rock. For example, like rocks, whether it is a fractured or unfractured rock, actually it could consider it as a aquitard. So as you can see from this diagram here, this section of this diagram, this layer here which represents the aquitard. So when we have an aquitard layer, it is considered as a fully impermeable. So in the top and the bottom section of this layers, we have this aquitard that is made up of clay, for example. So when we have the aquitard layer, it is considered considered as a fully impermeable layer that makes the aquifer below it under pressure. So what is the meaning of an aquifer under pressure, and what's the difference between having an aquifer, the aquifer under pressure, and the aquifer has no pressure in it? So the fourth example is we're gonna take a look at the aquifuge. So aquifuge, it stores no storage and no transmits water, so it cannot store or transmit water. So the example could be a granite. So the aquifer or the rocks without any fractures or joints can be considered as the aquifuge as a result. So it cannot store or transmits water. So the excellent example could be a granite. So a granite formation without, for example, let us consider a granite rock without any fractures or joints. It could be a best example for aquifuge. So from this image you can take a look at the different aquifers here. So for example, during a rain, the water just infiltrates into the subsurface or the soil here. You can able to see that. So this portion has a sand and gravel, and this line indicates the water table. So when a water can able to store and transmits the water, it is considered as an aquifer. And this particular layer is of silty layer. So previous we saw an example for an aquiclude where it can stores water but cannot transmits. So the example, the formation or we can consider clay and silty layer. So this particular layer can store water but it cannot transmits the water. And followed by below we have this sand and gravel aquifer. So it has an ability to store and transmit water. Similarly, during an infiltration here, you can able to see that. So the water gets stored in underground cracks and pores. These are the cracks and pores here. So as a result, the water stored in this cracks and pores are considered as a fractured rock aquifers. And this particular areas can be classified as a unsaturated zone, and this particular area can be classified as a groundwater zone. So this is a unsaturated zone, or this is the saturated zone. So types of aquifers, there is two major types of an aquifer. That is unconfined aquifer, that is opens to the earth's surface and to the infiltration. So you can able to see that this is unconfined aquifer, that is opens to the earth's surface and there is an filtration, so it allows the infiltration. But similarly, what is called as a confined aquifer. The confined aquifer is overlain by a less permeable material or impermeable materials like clay. So for example, this section of this the subsurface formation, so this section is called as confined aquifer. So water gets trapped in the top and bottom layer by an impermeable layers. So as a result, this particular section of aquifers are called confined aquifers. And when this water is open to the earth's surface without any impermeable layer in the top and the bottom section here, so it is called as an unconfined aquifer. And similarly, perched aquifer. So this is this particular area is called as a perched aquifer. So the perched aquifer is underlain by a low permeable unit here, or the material. So that is when this part of the section which has a porous media only in this part of the area, so in other part of the area doesn't contain any porous media. So when tapped for water, so this particular area can store only a certain amount of water, so it can yield very a lesser quantity of water. When similarly, when a well is tapped for in this particular aquifer, that is so that is a sandstone, that is a sand or gravel aquifer. So in this has a larger porous and permeable material. So when tapped for water, it can produce a larger amount of water compared to this perched aquifer. Able to see 4 different types of groundwater aquifers, starting from aquifer, aquitard, aquiclude and aquifuge. So stores and transfers water. Example is sand and gravel. And aquitard, it stores and transfers water less than aquifer. For example, sandy clay and shale. And followed by we have aquiclude. So it stores water but no transfer, so doesn't transmits the water. Example is clay. And aquifuge is it cannot store or transmit water. So example is granite. So this particular rock type, when it contains no fractures or joints in it, so as a result it cannot store or transmit water. So the groundwater aquifers can be majorly classified into confined aquifers and unconfined aquifer. A confined aquifer is a groundwater storage area trapped between two impermeable layers of rocks or sediments such as clay or a dense rock. This impermeable layer restricts the flow of water into and out of an aquifer. So for example, you can able to see from this diagram here, we have this particular area is called as confined aquifer. So this particular area is trapped between two impermeable layer. For example, the top layer, it consists of a clay, there is an impermeable layer, followed by in the bottom we have this bedrock without any fractures or joints. So this is this particular area is called as confined aquifer. And similarly, what is an unconfined aquifer? An unconfined aquifer, also known as the water table aquifer, so it's directly recharged by the surface water and is not overlain by any impermeable layer. So the upper boundary of this type of an aquifer is called as water table. So for example, this section of this area is represented as the confined aquifer, and this confined aquifer gets directly recharged by the river as well as the lake system here. So lake water recharges the unconfined aquifer, and also it is not overlain by any impermeable layers like the clay we have seen in the previous example of confined aquifer. And the upper boundary of this type of an aquifer is called as water table. So you can able to see this line. So this line here represents the water table. So now let's talk about what is the meaning of an aquifer under pressure, and what is the difference between having an aquifer under pressure and the aquifer has no pressure in it. So that is the main difference between the confined and unconfined aquifers. So the aquifer that was under pressure is bounded by an impermeable layer here. So in this case, you can able to observe the clay and bedrock. So it is called as a confined aquifers. While the aquifer that has no pressure on it and it is bounded by a water table, we can consider it as an unconfined aquifer. So from this diagram, you can able to see that the unconfined aquifer is not bounded by any pressure. So it has no impermeable layer. You can able to see from this image here. So what is the main difference between both of them here, the confined and unconfined aquifer? Actually, the confined aquifer, as you can see here, so first we have to ask ourselves a question why we consider this aquifer as a confined aquifer. Actually, because it is an aquifer as it can transmit and store water, and it has a porous media consist of some sediments, and the layer above it is it was a clay. As we said before, the clay is an aquiclude. It can store water, but it cannot transmit water. So as a result, the groundwater can move upwards. So the groundwater here is under pressure. So as you can find here, when we drill a well here, we could consider it as an artesian well here. So the artesian well means well that was drilled in the confined aquifer. By drilling that well, we will have the water flow upwards without no pumps, due to the result of the overlying burden of this the pressure of this overlying material. So this particular material can store water, but it cannot transmit. So it exerts a certain amount of pressure on this aquifer here, that is the confined aquifer. As a result of this pressure, the water can, when drilled on this confined aquifer, the water can move upwards without any pump. So basically, we don't have to pump the water out here in the confined aquifer. So the water goes out by the effect of pressure. So while here we have this unconfined aquifer, why we considered it as an unconfined aquifer? So as we said earlier, in unconfined aquifer, it has no aquiclude above it, that is no impermeable material above this aquifer. So it is just bounded by the water table. You can see this line here indicates the water table. And actually you can find another important difference between both of them. So when we take the water from this confined aquifer, actually the level of water here does not decreases. So while in the unconfined aquifer, the water table decreases significantly and very fast. So while here in the confined aquifer, just the pressure will decreases. By decreasing the pressure, so the water level that begins to decreases gradually. So now let's take some examples. So let's discuss about this section here. Actually you can find this recharge area. So this is this particular recharge area containing a porous media that can store and transmit water. For example, sand. As we know right now, there is a recharge area, means an unconfined aquifer. So as we can find here, the aquifer here can be considered as confined and unconfined aquifer. So how is that? So we can find here the water table is. So okay, so it is a recharge area. The groundwater recharged from here. So this is a recharge area. So groundwater gets recharged from here. Then we have the water table. So the aquifer is bounded by water table. So this part is considered as an unconfined aquifer. So while we go as in this direction, you can find this confining units here, whether it is an aquiclude or Aquitard. So these are the confining units. So this gray color which represents the confining units. Okay. So that means the water level or the potentiometric surface. So this is the water level and this is the potentiometric surface here, which is represented in the dotted line here. As expected to, so this line here represents the water table and this represents the potentiometric surface in the dotted line. But actually the confining units forces the water to be like that. That means the water here is under pressure. So when we drill a well here, we can find that amount of water that flows by the pressure effects. So we could find that well called as an artesian well. So because this confined aquifer is constantly under pressure due to the overlying and underlying confining units, so which are exerting a certain amount of pressure on this confined aquifer. As a result, the water flows up as due to the pressure effect, and the water from this well is called as artesian well. And this well is also, it is tapped on the confined aquifer, so it is called as an artesian well. While on the other side, we can find here there is an unconfined aquifer. So why it is considered as an unconfined aquifer? Because it has no confining layer above it. So the water table is on the surface of that aquifer. You can able to see this is the water table. So it is considered as an unconfined aquifer. So when we drill a well here, so the water does not go up by the effect of pressure. So we need a pump to pump the water or to discharge the water from this unconfined aquifer. And also here we have another type of an aquifer that is called as perched aquifer. You can able to see that. Actually, the perched aquifer is the amount of water that infiltrated, maybe due to the excess of irrigation, or maybe due to the excess precipitation from the surface, and so that the water infiltrates and finds a confining unit, so the water accumulates on it like that. You can able to see that. And this is called as a perched aquifer. So when we drill the well on this particular perched aquifer, it does not yield a large amount of water, as it can store only a certain amount of water in this confining unit compared to the unconfined aquifer and confined aquifer. And also this perched aquifer is also called as we can call as a temporary aquifer. It's not the permanent. So we have to study the geology of this area very well. Why? Because we may drill a well here, as we can find. So when we drill a well, we could find a water, but this water is temporary, which means that this perched aquifer is full of water in some seasons, like in the wet season. So during the dry season, the aquifer will be empty. So we cannot, this perched aquifer will be empty. So we cannot consider it as a permanent source of water, because it gets recharged only during the wet season. Now let's take another example. So this is also a same aquifer. So it is considered as an unconfined aquifer. From here, this portion of this area can be considered as an unconfined aquifer, and this part of the section is considered as a confined aquifer. So as you can find an Aquitard above and below the confined aquifer. So this is an Aquitard, and this is also another Aquitard. So this is considered as a confined aquifer, and we have this artesian well right here, and this particular section is called as Vadose zone. So the Vadose zone, also termed as an unsaturated zone, is the part of the earth between the land surface and the top of the phreatic zone, the position at which the groundwater is at atmospheric pressure. Hence, the Vadose zone extends from the top of the ground surface to the water table. So the Vadose zone is considered from this part till this part of the which represented that this is the water table. So these areas in the brown indicates the Vadose zone. So the Vadose zone is another name for the unsaturated zone. So taking another example from this figure, we can able to find there is two type of an aquifers. One is of unconfined, and followed by we have confined aquifer, and below we have another confined aquifer. So the first one is called as an unconfined aquifer, and the second and third are confined aquifer. So from this figure, you can able to see that the unconfined aquifer get recharged from the rainfall. As a result, the water percolates into the surface, which reaches the unconfined aquifer. So the unconfined aquifers also get recharged by the river or the stream. So this water from the surface gets percolates into this unconfined aquifer, and this part of the area gets recharged. So also here you can find a divide that is a confined aquifer and an unconfined aquifer. So this dashed line is the divide between the unconfined aquifer and the confined aquifer. So actually we said before, it depends on the water level and the presence of the confining layer or the Aquitard. So this is a confining layer of Aquitard. So you can able to see here. So if we drill a well here, the water will not go out due to the pressure. So we have to put a pump here to discharge the water. While in the unconfined aquifer, so that is in the unconfined aquifer. So this section represents the confined aquifer. So when tapped for water, the water doesn't come up. So we have to use the pump to discharge the water from here. So in case of the confined aquifer, so in the confined aquifer, we just need a drill a well. So the result of the pressure difference, the water from this confined aquifer flows out due to the pressure. So the wells in the confined aquifer doesn't require an eddy pump to discharge the water out. And this well is also called as an artesian well. So in this video we have seen a detailed information about the groundwater aquifer. So the aquifers are the geological formation that stores and transmit water. So types of aquifers, we saw aquifer, aquiclude, aquitard and aquifuge. So the aquifers can be classified into confined and as well as unconfined aquifer. So the well drilled in the confined aquifer can be an artesian with water rising due to the pressure. So an unconfined aquifer requires a pump to extract water. So the burst aquifer is a temporary water accumulation above a confining layer, often seasonal. So the importance of geology. So understanding the geological context is crucial for groundwater management and well drilling. So different aquifers have varying water availability and extraction method. So in this video, we have gone through a detailed about the groundwater aquifer and its classification. So thanks for watching, and please subscribe to our channel and give us a like.